Hello everyone and welcome to my YouTube channel. I am Varshini from Sri Venkateshwara College of Engineering. Today we will look into two questions from the subject CAD. The first question is a rectangular lamina of 35 into 20 mm side resting on VP with one of its shorter edge in such a way that it is tilted about its resting edge till it appears as a square in the front view. The edge on which it is resting is inclined to HP at 30 degree. Draw its projections and also determine its inclination with the lamina with HP. Now, before we solve any question in CAD, we draw the XY line. After considering the XY line and the HP VP lines, we'll draw the rectangular lamina. We can start with one line and we can just leave the cursor. Dimension is 35 degree, 35 mm and 0 degree, 20 mm and 90 degree, again 35 mm and 180 degree. Later we can join this manually or we can enter 20 mm in minus 90 degree and we'll have our lamina. Let us quickly name the lamina. So what we'll do is we'll use thin lines or normal lines to extend our side. When we can use Intel sketch, the arrow mark determines that it is the end of line and we can join it to VP. Now from the end point C we can extend it up to the XY line and here we can join and make this one a visible line because that is also a view. We have to name this line now. We see from the top view the point A will be visible because it is above and below is the point D which will not be visible. So that points which are not visible are placed inside the brackets. Next given condition is that it appears as a square in the next view. So what we'll do is, so we'll consider a square of 20 mm. 20 will be the side and 0 will be the degree. Again 20 mm, 90 degree, 20 mm, 180 degree, again 20 mm and minus 90 degree. We have a square of 20 mm side. Let's name this quickly. Okay, now that we have named our lamina or the square that we created, we can draw the extended lines and extend this line. Now from the other end, wait for the end of line Intel sketch and also the perpendicular line Intel sketch. We can see that line next to the cursor. Okay, so the inclination is not given, but it is given that the view formed is a square. So we have constructed a square before. Now we will try to find the inclination of this line. Now what we'll do is we'll select the view we have generated previously, and now we will use the move tool. We'll use it with copy and move. From this endpoint, we'll move it and place it on the point here. Now we will rotate this line until the point B of C meets this line. Now if we check the angle between the two lines, XY line and the given line. So next what we will do is we will 30-degree line from the XY line. Then we can extend the line up to a certain extent. Now we can copy this square and place it on this line along with the annotation. We can copy it and move with a copy. We can select the sides for copying, place it on the thing, and then we can switch to the rotate tool, endpoints Intel sketch symbol, and now this object is placed on the 30-degree inclination that is mentioned in the question. Now we'll use the line tool to draw the extension lines. We have one extension line from A. Keep the line tool active. From B, we will extend another line until the. We'll just extend the line until we get the point B intersecting with B. So we'll just extend the line 90 degree. we can extend line from C also. The point C is also below only, so we can extend this line also parallel to the previous line. And from point D, it is the point D, we can see it is on the XY line here only, so we can just let it be over there. So now we can draw one extension line from here parallel to the XY line and let go. We can use a trim tool to trim off all the excess lines to avoid confusion. Now we can join our view using a visible line. From here, we can start from a point A. We will join the points from point A to point B, from point B to point C, which is right next to here. We can use the Intel sketch. Point C to point D, which is the end of this line, and again D to A, which will complete our figure. And we can name the parts of this diagram. This completes the first question of today's video. Moving on to the next question. A pentagonal lamina of edge 25 mm is placed on HP with one of its corners such that the plane surface makes an angle of 30 degree with HP. The perpendicular bisector which is passing through the resting corner appears to VP at 45 degree. Draw its projection. Draw our XY line. We will name the line as X and Y. Here we have X and here we have Y. We will also name the HP VP conditions. First we have VP above the line and we have HP below the line. Now first we have a pentagonal lamina, so we will use a visible line to draw the pentagon. The angle for pentagon will be 72 degrees and the edge of the pentagon is given as 25 mm, so we will have 25, enter, 72, enter, 144, which will be 216, so the side will be 25 as usual and the angle will be 216. After this, we'll have the side as 25 again, and angle will be 288. We can join these two sides to make finish off our pentagon. We can rotate the pentagon such. Yeah, we have the required pentagon now. Now we can start by naming our pentagon. In order to get another view of this, we'll have to project the line. Make sure the lines are normal lines. We'll start from A, extend it till the XY line. From point B and D we have the same line. From point C and D also we have the same line projected upwards. For mentioning the direction of projections, we can use leader lines and show the direction of the line extensions. Now we can use a visible line to mark out the distance of that we are used here until the given inclination is 30 degrees. So what we'll do, we'll select along with the annotation, we'll select this line and we will use the move option or tool, but we'll remove a copy. So we'll select the endpoint and place it a little away from on the line. Now we'll use the rotate tool. We have to specify a starting point and ending point, the start of this line to the end of this line. Now we can see when we click tab and we enter the degree we want it to be tilted in or the angle we want, 30 degrees, so the line is automatically flipped into the 30 degree. We can just use the tool arc by center, check the radius, it's 14.69, so we can choose this as the center now and we can type in the radius. We get an arc, we get to draw an arc at this point. We have a small arc that we have drawn at 14.69. Now we can use the endpoint tool and then draw an extension line. From the arc we can make out zoom. Yeah, we can see the small arc I've taken here near B and we can fit it back. From there I have driven an extension line and now we can do the same from A also, and because it has to join here we can use the dimensioning, yes, until A, and we can actually like we can join here to A so we get the exact point. For B and E also we have this line we have constructed. We have E, we can join it, and for C and D we can just align, we can use this alignment and place it near C. We can join it to point C, and from D we can extend it again up to the line. Yeah. Now we can use a visible line and draw the desired shape or the shape that is obtained from this construction. Start from point A to B, from B to C, from C to D, D to E, and E to A again. We can name it again. Now that we have named the diagram that we have constructed, we move on to the next step. The next step states that it appears to be resting at degree 45 degree. So we'll first construct a 45-degree angle downwards from the point. The length can be spared. We'll just enter 45 minus 45. So we get it downwards and not upwards. We'll just draw the line. Now we have to place this given figure on the point such that the point A is on the axis of the line that we have drew. So we'll use the select tool and select the diagram completely along with the annotations. We'll move a copy and select the point on which we want to move. We can place it a little below. And now we can use the rotate tool to select the 2 points for rotation. Initial point, we'll use the midpoint as the final. And now we can place it on the axis. Now we have the pentagon given view. Now we'll extend the lines from, and now we can change the line thickness to visible and join our points, starting off with point A to point B to point C to point D to E and to A back. With that completes the view. So this completes the projection of the pentagonal lamina in the conditions given. Thank you for watching.